What up, ladies and gentlemen? Jesse Warden here. Today we are going to attempt day one of Advent of Code 2019. There are 2 challenges per day for 31 days. And the goal is to use any programming language to solve these challenges and rescue Santa Claus. He's been traveling all over the world. And so, what we're going to do is try to help him by completing these code exercises. You can use whatever programming language you want. I'm going to use Elm. I used it last year and got to exercise 7 in the course of 27 days. I think around January 4th, I gave up. I was so behind and they were really hard. So they start reasonably challenging and then they get successfully really hard. A lot of these algorithms are not things that I use in my day-to-day job. So let me get the actual URL for this. I'll share it out on social media and then we will get started. Streaming live. Advent of Code. Advent of Code 2019, day 1. Challenges. I will save it here, and I'll go on LinkedIn and do it as well. Start a post. No need for a preview. LinkedIn, thanks anyway. All right, so what we're going to do is we've already set up our code to do this. So let's go to the Advent of Code website, and what you can do is when you log in, it will show the current challenge for that day. So we're going to go to day 1. And let's read the challenge. Fuel is required to launch a given module based on its mass, specifically to find the fuel required for a module. You take its mass, divide by 3, round down, subtract 2. So for a mass of 12, divide by 3. All right, so we can create a function. We can do the math. Let's open the REPL real quick before we start messing around with real code here. I will make this a little bigger. And let's go to Elm REPL. How's that look on the live stream? I'm a little behind on the live stream. It's a little latent here. I'm going to do, let's see, what they say, a mass of 12 divided by 3. All right, so let's do calculate mass, which takes in a mass and gives you the fuel back. So let's see, it equals mass divided by 3. I'm assuming these are floats, but maybe they're ints. So let's just do that for now. Round down by 4. Divide by 3, and then round down. I forget how to do rounding in Elm. All right, I'm going to spend a lot of time here in the Elm docs trying to remember all the core libraries. I haven't touched a lot of the math stuff in forever. Let's go to the basics and go to round. Round. Is it to float round or is it just round? It's been a while here. Round for ints and floats. So it takes a float and gives you an int. Okay, so we'll assume it's there. That's fine. So we'll say round takes the mass divided by 3. Is that round? No, we need floor. Let's do floor. Floor. And then subtract 2. So take the mass, divide by 3, round down to get 4. Take the mass, divide by 3, round down, and then subtract 2. Okay. So assuming we calculate mass for, let's say, the mass is 12, divides by 3, rounds down to 4, and subtract 2, you get 2. So if I do calculate mass of 12, I should get a 2 of an int of 2. Fantastic. If I do the exact same thing with 14, I should get a 2 as well. If I do the exact same thing with 1969, I should get 654. So far, so good. And if I do the exact same thing with, goodness gracious, 33583. All right, so I think our algorithm's good. The fuel container upper needs to know the total fuel requirement. To find it, individually calculate the fuel needed for each mass of each module, and then add together all fuel values. What is the sum of the value? Okay, so I think what we should do for now is write a list control that shows the input, the output, and then we'll add them all together at the bottom. So let's just do a text field. Yeah, let's do that. All right. And we're going to have to modify our types here. So instead of a count, we'll say initial input of our thing, which is a string. By the way, if you're not familiar with Elm, Elm is a strong type language, which is functional. It's the whole goal of using it is to ensure that when you compile, you have no runtime exceptions. And 99% of your time writing in Elm is writing something and the compiler breaks. So you spend 50,000 times reading these compiler errors. And the reason you do that is by the time you are done, it will compile and work. So that's what we're going to do. We're going to fight with the compiler here. So our initial input's a string, and we have a list here of modules. I think, let's say module list, which is a list of modules, and a module, I don't know, is an alias, which for now, I guess the module has a, I don't know, it's a good question. Just a mass, I guess? I don't know, what is it called? We got to get our naming right here. A mass for our module. So a module is based on its mass. Okay, so we'll just say, I don't know what it is. We'll just say the mass of that particular module, which is an int. Okay, so we have a list of modules. Each module is going to have a particular mass, but it actually has a starting value. So we need to give it fuel, which would be also an integer. So we start with a mass, but actually I think it starts with a float, doesn't it? I think it'll be all right. It'll be all right. If you round down, it'll be fine. So type of module starts with the mass. We calculate its fuel for each individual module. We then have a list of those modules. And then finally, we have a total fuel required, which is also an integer. Okay, so that'll give us our model. The initial model, if you ever use Redux, this is your default value for your reducer. Let me guard your privacy, blah, blah, blah. Let's try our initial input, which is everybody's input is unique. So if you've never done Advent of Code before, although the algorithms are the same for each exercise, you get 2 a day, the input for your particular challenge is different. So mine's going to be here, this puzzle input. Yours is going to be different. Everybody's going to be different. So although you can go to the chat rooms and mainly Reddit and look around how people solve it in Reddit, the actual solution might be cool, but it's still going to give you a different output than theirs would. So very, very challenging. So I'm going to do initial input of just an empty string for now. And the module list is an empty list. And the total fuel required by default is 0 because we don't know what it is since we have an empty list. So that'll give us an empty list. And then from there, we need to change our UI here to have a list control. So let's go explore some UI. Most people are just writing code for this, but I'm making it extremely hard and adding a UI. Let's get ourselves a card. Let's go to the demo. So we'll say card, and usually it'll have in his demos. Yeah, we can get a demo card here. Title, resources, example card 1. Let's copy pasta coding for the win. And view. Let's go ahead and put our example card here. Actually, I'll put this at the bottom. Examplecard1.com. Hit save. And we'll get rid of all this insanity. Can't find the card variable. The card variable is a card imported from the card material design components. Let's go ahead and import those at the top. Cannot find HTML attribute style. So we are not using Elm style. I love it. It's good to have strong typing with your CSS, but I'm just going to do the old school way. So we're going to expose everything by hand here. Demo media. Let's find demo media. So in the demo, he has some. Oh, great. I don't want images. Demo media. I don't need this. So no need for images. However, demo title. This is Gigantor. Nothing like a Gigantor text field and a typography of headline. Let's go get our typography. Typography is the material design way of doing CSS encapsulated in the material design way of doing things, which is Google's design system, if you're not aware. Material design is a Google way of building things for Android and web, and they have some web components, and this German created an Elm wrapper around it, and that's what I'm using, this material stuff. So a lot of this is actually not pure Elm, it's web components with a strongly typed wrapper. So there's a lot of JavaScript and CSS that I don't have to handle, thank goodness. We also need the theme, so let's get the theme up here. Copy pasta coding for the win. Got to get the demo body. As you can see, my compiler is solving all my problems, and I literally just go, oh, copy pasta, oh. Well, that's why I like Elm, because you can be really stupid, and it solves all your problems. And account. Okay, so we can't do account in our updates. So we need a default. So let's say load default input. We don't need two messages. So we'll just say default input. And for, whoa, careful. Load default input. So if you're familiar with actions in Redux, messages are the exact same thing. You say, yo, I want to do this thing that could potentially change my data. And it goes, cool. You need to handle that. Tell me if I fire this, I guess with no parameters, what kind of model you're going to return and what kind of action should I take? And I'm like, well, home slice, I want you to do absolutely nothing with the model. Take what you got and return what you got. So don't change anything. And by the way, don't do anything. Elm's like, cool, bro. Or Changing Planet by Kurt Wagner. Changing Planet. Well, our planet isn't really changing right this second because we have a static model where I've changed nothing. All right, let's get our input here, and we're going to put this at the bottom. And my puzzle input is going to be different than your puzzle input, so I'm going to copy pasta coding for the win. Let's go down to right above subscriptions here. We'll say puzzle input. And go ahead and add a type for it. Puzzle input is a function that returns a string. It has no inputs. And I believe in Elm it's triple double quotes to do multi-line strings. So we'll use that as the input. And let's just verify we can actually read this real quick. So let's take our puzzle input and put it at the bottom because it's so obnoxious. How obnoxious? So obnoxious. Put that at the bottom. And let's go to our view function here. View colon. And what we're going to do is take rid of all this. Let's, right below our card, put a div tag with some text in it. And let's see what our puzzle input is. We'll say model dot initial input. Stephanie, need input. And right above that div, let's put another, I don't know, break tag. Yeah, let's put a bold tag. How about that? Do we even have a bold tag? Probably not. Say bold. There we go. Now we do. We have a bold tag. Bold. Puzzle input. Let's give that a shot. And this needs a comma. Whoops, my bad. This is another div here. All right, 1 second. I got commas all jacked up. There we go. All right, puzzle input is nothing by default, but if we click a button, it'll load the input. So let's put this inside the card, and we'll give the card the model because it needs to draw stuff. So say you take a model and you return an HTML message, which is very similar to React, where you, or Vue, where you say, yo, here's some data, I need you to draw this. from our model inside of our block, I think. Yeah, right here. We'll paste all our crazy stuff. So we have a list of HTML stuff, if you're not aware. And why is she mad? Why are you mad, bro? Oh, because it returns a card block? That's no bueno. What's wrong with the demo title? Talk to me about demo title. The compiler's mad that I have a puzzle input that does not return a card block message. Okay, let's take a look at this demo title here. Oh, because he has a div of that. Okay. Let's put it inside him then. Okay, I can do that. I can do that. No biggie. We'll go inside the demo body, which then takes an HTML div and then converts it to a card block, which is completely fine. All right, we don't need this obnoxious stuff here. Everything's on the root. Where is it? It might not be on the root. Okay, typography is not. That's okay. That's all right. All right, so he has text here. We're going to change that with our input here, which is a div and another div. And he takes the model as well. You take a model and return a card block message. Go find our demo body and give him the model. Okay, cool. So we got a puzzle input. Let's show our demo body's puzzle input, which is the initial input. Okay, let's give him a body. So we're gonna have to put a button in the actions. If you don't know what I mean by button in the actions. So the way cards work in material design is you have your content, and then you have in the bottom you have actions, which is kind of like the area where you put things to interact, right, with the data on the card. So we're going to put some buttons here. So I have a raise button. I'm going to change that to a text button. Let's do that. I think it's text button. It'll still work with the same button config. And then go to view, example card. All right, we need to put it in here. So actions, it's a maybe. Gross. Okay, how do we do demo actions here? Show me how this works. Oh, so you say just demo action. I can do that. I can do that. I can do anything for actions, but I won't do that. Demoactions.com. How does this work? Demo actions. It's an array of weirdness. That sounds great. All right, we'll put it right below our demo body. And what does it show? Icon button config, which my assumption is this is from your icons. Okay. I don't think I need this though. I don't need icons right now because I'm not going to do this kind of stuff. So let's get rid of icons for now. We're not doing icons. We're just doing buttons. Okay, they have read and bookmark. We don't need that. What we need is load inputs. This will load our puzzle inputs. And our load input is actually an action, which means it's going to use the default thing, but we need our on click to actually do an action. So what that means is when you click a button, it dispatches an action to say, yo, we want to change our model based on this particular action. If you're familiar with Redux, it's like when you dispatch an action creator for your reducer. So we are going to adjust this button config to have, and give me a code hint, I can't remember. Is it on click? I think it's on click. Yeah, let's try on click. On click equals just load default input. And I think that's correct. Is that correct? I can't remember. How does he do it? Is there an on click in here? Let's see how he does it. No, his doesn't actually have the demo actions, which does not have the buttons for the card actions. Okay, I need to find a card that is dispatching because I can't remember the type. So that's demo. Does he have an example of a button card? No, he doesn't. Crap. All right, I need to figure out a card action. Man, this is going to be rough. All right, let me find the card demo. Card button action. Oh, interesting. Okay, so it might be for the button. Okay. Cards demo. So I can't do. What's wrong with doing an on click for this guy? On click is maybe map HTML events on click. Okay, that's fine. He's just making it easier with a click handler. That's crazy. Okay. Yeah, it's the same thing. You're passing an on-click event, which has whatever your on-click that you pass in, which is your events. Okay, that's fine. So why doesn't it like it's going to a message? Oh, okay. What if I do this? Example card 1. Example card 1. I forget why you allow parameterized messages. I can't remember. Okay. There's a reason for that, and I'm too stupid to know. But let's verify, just be crystal clear. For now, we'll just do logs. We'll go to update, and we'll say message 1, logs up. Input, bro. All right, we're good. We got clicks going. Going strong. All right, so load our default. God, I can't even spell default right. That's embarrassing. Is that how you spell default? I am so tired. I've been programming for 20 years and I can't spell default. Yeah, that's right. Okay. To get our default input, we actually need to adjust our model here to get our puzzle input. So we want to change our model. And this is like destructuring if you've ever done immutable changes to objects in JavaScript. We're going to change our puzzle input. What's the model again? Initial input. Yeah, I'll say initial input equals puzzle input. And so when we load it, it'll load our puzzle input into there, which is good. It's a list of numbers. And so that is the array of numbers we're going to have to parse. So let's do this old school. Let's do our puzzle input. Where's the card size here? Card. I'm going to make this a little bigger. Hey, what's up, Wolf Mason? Thanks for stopping by. You're going to enjoy yourself until I get to recursion, and then it's going to be a horrible show because it never works out well. All right, so we got 350 pixels. I'm going to make this guy 800 because I want to add some room. Yeah, we're going to add some room here for the puzzle input around this. So let's go ahead and hard code our div for that guy. Where I load it up, I want to shrink it down again for the puzzle input. So let's go puzzle input. Yeah. So this particular div here, I'm just going to say a width of, I don't know, 120 pixels. Let's just see what happens. Nope. Let's do, is this the actual div itself? Oh, ew. Yeah, we don't want the bold. We want it on this guy. Much better. Okay. So we got our puzzle input for that. And let's shrink it down a bit because each one of those I think might have a line break. Let's try 80. Yeah, good enough. Good enough. Okay, so that's our puzzle input. That'll give us our inputs on the actual list control there. And let's do some old school parsing here. So we'll show our div. This is going to be our, actually we need another one, don't we? We do. Modules. All right, time to whip out the flex box because I want my modules off to the right. So let's get rid of this guy. And we'll do style, display, flex style, flex direction. I always get confused between column and row. So let's see. That's column. That's row. All right, so we're going to break this out into subdivs here. And then we'll change these components later. I know this is kind of smushed together. We'll change it. Just give me a minute to group them up, and then we'll organize it into actual functions that are readable instead of a mess of div tags. If you can't tell, I am horrible at HTML. And just because Elm gives you pure functions doesn't make me any better. All right, now that we have that, let's go ahead and make this one the master div. Actually, that's fine. Let's try it right here real quick. It's a row. Good. Very good. Okay. And then your width here. The display of the width. The width is, what do we say? It was like 80 pixels is good enough. Yeah, very good. Okay, so that's our puzzle input. Our modules are going to be to the right of that. So we're going to have to go and parse those modules. So let's make a new type to make a parsing a separate step. This is a very common thing I've done, is to load the input to show it in there and show what it is, because this sometimes is actually a text field. In past places, I'll make this a text input, and then you could, change it with your own input if you want to test stuff. So now I'm just going to use it for mine. We'll change it later to a text input or text area. And then parsing is the second step, because in later things, they give you a lot of inputs, and it's a ton of parsing, which is really slow because I write really slow parsing code in Elm. So we'll say parse input, save, go to our update function, and let's write our parsing function. So for now, we'll just say nothing changed. We'll say model command none. And let's go ahead and create a button for it in our view. Example card 1, where is my actions, demo actions? A lot of actions. What? All right. We're going to do a card action button with a button config of onClick equals just parseinput.com. Parse input. All right, that'll run our input, and then we can parse our input. And that will handle our modules. So I think the goal is to parse each one of these line items as an integer, and then create a module from it with a default value of 0 for the fuel. But I guess we could parse it the same way. Let's go ahead and do that. We'll do that. All right, let's go to update. And we'll write a, here. Where is view? Yeah, let's copy this for everything here. Whoa, careful, Jesse. Careful. Don't build walls. Build bridges. Sam Porter Bridges. Porter for duty. Let's go to subscriptions. Subscriptions. And we'll do the same thing for update. Okay. So we need to write a parser function here for our inputs. Let's say parse inputs. And what you're going to do is get a big old, I don't know, input string. And you're going to output a string. You're going to get a list of, what is it, modules, I think? Yeah, a list of modules. And so how do we parse? Well, first thing we got to do is remove the other stuff. Let's go look at how we did this in the past. I literally did this the first day. Let's go check it out. Like the Funk Soul Brother, we're going to check it out now. and refer to how we did things in the past. Let's go update. And so we did a string splits on that to actually get a list. Okay, let's test that out. Let's see how that works. I'm gonna print that out into the console here before we commit to actually a parsing algorithm. So we'll say message1 log split, and we'll do a string.split on the input string. And I might have to input string. Yeah, let's go ahead and do that. Import string exposing split. I'm gonna do one function at a time here. Actually, who is he getting his input from? Parse inputs. Okay, let's do actually, let's use it for real. Let's use it for real right now. The parse input will get a module list here. What's the module? The model? The model is a module list. Module list. Okay. Module. Whoa, careful, bro. The module list is whatever parse inputs is of the model dot initial input. All right. So when we parse the output, ballin', we got a list of strings. They ain't quite ints, but we'll make it. All right, how do you parse a string to int? I think it's, is it from string? Crap. Is there a to int? Nice. Oh my God, it's a maybe. Okay. This is where things get frustrating. All right, so the problem with maybes is that those are not ints. We can't do anything on a list of ints. So we're going to have to default all the maybes to zeros, which for now we'll just assume is not the end of the world. So, all right. This is frustrating. What we're going to do is get our list, and then from the list, we've got a map over each one of those maybes, right? It's going to be an M, a maybe, because either it successfully parsed as an int, or maybe you give it a string of cow, which is not an int, so it's going to give you nothing, which means we have to case on each one of these and say, all right, if it's a nothing, I'm sorry, if it's just a value, great. Go ahead and return the value. But if it's a nothing, then you have to give 0 back. And that'll give us a result. And if we log out our result, it'll give us that back. Give us a list of strings. And we want to map each one of... Oh, right. I'm sorry. That's not true. First, we got a list map string dot... What is it? From... To int? Yeah, to int. Sorry, my bad. Okay, so first loop through all these, convert it to an int, maybe, and then from those maybes, either get the number back or get a 0. Okay, so I don't see any zeros, and I don't think my input had any zeros. So I think our input's clean. So we're just assuming good inputs here. So now we have an array of ints. And then from that, we can map each one of those. Wait, sorry, I'm stupid. There we go. And then from each one of those, we can convert it to a module. So let's do a list map. We get an input, which is an integer. And we want to convert that to a module. And a module takes 2 parameters, a mass and a fuel. So our mass is the actual input, and the fuel is defaulting to 0 because we haven't calculated it yet. And so when we parse it, we should get an array of fuel of 0 and mass of 0. Okay, so far so good. Now we have to calculate those modules. I think we can just do it in the parsing step. So let's take the algorithm we wrote in a REPL, which is calculate mass. And it takes a float, but I think we're okay taking an int. Let's see what happens. It might be okay. I don't know. Parse inputs. Let's say calculate mass, and let's fix its type definition. It takes an integer and returns an integer. And I don't think it likes the mass because it's expecting a float. Is it really taking a float? Oh, because I'm not doing integer division. Okay. The argument is int, but floor needs a float. What if I just don't do that? I don't know. I'm not convinced I need a float yet. So let's just do that and assume it's all integer division. It's never going to get a decimal. There's no need to round down. I think that'll work. Okay, so now that we have that, we've got to loop through each one of the modules, and we have to calculate the mass based on the integer, which means instead of 0, it's going to be calculate mass of int, right? And that'll automatically count the fuel based on the mass. So that means our inputs have that with the fuel and the mass. Okay, that's cool. So now that we have our data, let's go ahead and module list, and then I don't think I need to really print this out anymore. So let's just go ahead and return our module list instead of an empty list, and that'll set our model with the data. Now let's go draw it. So now that we have our data, we're going to draw it, and I think if we just do a list with text for now, it's good enough. I'd really like to design some kind of like battery thing. Hey, Philip Kerman. Good to see you, buddy. Long time no chat, man. I know. If you take the most challenging language that I'm not good at, and it forces you to do UI, and I do it. I hope you're presentable, gorgeous. Philip Kerman. Remember him? From Oregon or somewhere up top left of America. All right, so
how delayed is it?
No, it's like 5 million light years delayed. I think it's like 15 seconds. All right, so I'm gonna find the list here. Where's my list? Modules. Okay, so instead of text, let's go ahead and make this in a list here. And we're gonna go list.map of our module, and we gotta import an HTML message out from that. And what we want is our model dot. Is it a module list? Yeah, module list. All right, we're looping through our module list, and we're going to get a module. And what we want is, I don't know, I got to create a function for this. So we'll say view module, and it takes a module in and returns an HTML thing. So we'll say view module. I take in a module, but I would like to give you back an HTML thing. And then from this, I want to give some kind of div that has two things in it. The first is it has a bold tag, which has the module, I'm sorry, the mass, and the text of the mass, which is the module mass. And then it has another bold tag, which shows the text of the fuel. And this will get us started, but I'd really like to create something cool with this. I don't know if I'll have time. Module mass, module fuel. And then each one of these need to be converted to a from int, I think. Yeah. Is that right? That's how you do it? Okay. And then we want a view module. So I don't even think I need that. I could just shove that in there. There we go. All right. And then view module. Oh. How about module yo? It might be a keyword. Let's do that. There we go. Okay, list map is taking a list of a list B, but div needs a second argument to be a list of HTML message, which is fine. So we'll do this first because that'll return a list, and then it's expecting a card block message, but I'm giving any message. Oh, I know why. Okay. Let's do this first. Where is she mad? The left side needs to be a function, so... All right, let's do this instead. We'll do... We'll convert it to a string first. I think I did that backwards. Maybe that's why. Maybe that's why your code is compiled, Jesse. How are you at reading compile messages? Clearly horrible. All right. So if we go back to what we had, it gets mad about the message return value. That's okay. All right. So far, so good. Sumant, what's up, man? Is creating a website necessary for the challenge you're working on? Absolutely not. Most of these challenges can be done in 5 minutes using Python or JavaScript, or 6 minutes using Lua. I am a crazy person. I want to not only do it in a language I'm horrible at, but I also want to create a UI because I need to get better at CSS and HTML and everything. So it's just to make it extra challenging. You know how you play video games and like there's story mode, easy mode, normal, right, for gamers, and then like expert mode, and then like super pain. This is like super pain mode, right? Functional, statically typed, strict language with a UI, right? I'm just making this impossible. So yeah, which is why my code's close, but then as soon as I get a compiler message like this, I forget. All right, so the body's card block, but demo body, I might be able to just change demo body not to do flexibility. I might be able to just say message, and it might just work. Yep, there we go. Okay. Cool, so we have a mass and fuel for our modules. We're parsing correctly. I think the concern, though, is it's a little too short here. Let's make your flex a little bit bigger. Cool flex, bro. Load the input and then parse it, and it's still too big. It could be my flex. What is it? Flex grow, maybe? Flex grow? I always forget. Flex style, flex. I'm going to have to Google it again. I'm so bad. Is it 2? 2. Yeah, that should work. Crap. I'm so bad at this. Troy, you are just psycho. Assembly. I can't do assembly. Does Elm have any? No, but it does have a maybe. And the problem with maybe is that you're then forced to do nothing, which means you then have to default with something. So if you did any, you have to default with something, and sometimes that something's wrong. Like if I parse a string, let's say it's 721, it'll be just a number, right? Parse correctly. But if it's nothing, that means it couldn't parse it. So does that mean it's 0? Sometimes that's okay, but sometimes if you add 0 to nothing, it doesn't change, and it should have been a 1, right? Maybe it was like a space and then a 1, and the parser couldn't figure it out. So an any is not, or maybe still not good enough. So VS Code theme. So actually on this Mac, it's actually really, really dulled down. On some of the newer Macs, it's way bright. Like the glow is super. This is called Synthwave 84, I think. Let me see if I can remember. I can't remember. Synthwave 84, yeah. And it's got the custom glow added, which means every time you launch Visual Studio Code, it says that your code appears corrupted, which I'm like, yeah, corrupted. And then use Fira code, so when you do like your arrows, they actually look like real arrows, and your equals look kind of cool, and it does some cool things with like backslashes and stuff. All right, bear with me. I got to debug my Flexbox. I'm like so bad at CSS. This is gonna be embarrassing. All right, so my master div is this. What if I say width of 400 pixels? Okay, cool. So it's not the width. Why is his growing? Oh, you know what? It's because it's wrapped. I'm stupid. All right, let's first put those in rows. Rows, baby. Object. No, there's no object. Everything's a type. And so, like, let me show you an example. So this is like an object, like in JavaScript, right? And if you think of like an object has a name value pair, just like in JavaScript or in Python dictionaries, where it has the name and the value, you can do type aliases, which were similar to like classes, like instances. So you say name value, and you define what the type is. So when you instantiate this model, this has to be a string, this has to be a list of modules, and this has to be an int. You could put maybe if you wanted to. And so when you instantiate it, it looks like this, right? So it's kind of like an object, but you can't do like no value, like an object which could be anything. Like you're not really allowed to do those kind of things. So real quick, let me put the stupid fuel and mass in there in their own div. Okay. So where's the bold? I'm in Crazy Town. There we go. Okay. Yeah, so these need to be in their own div. I just can't get over the assembly comment. That's just Crazy Town. Crazy Town. I saw somebody, I think last year, was doing it in either awk or bash. I mean, that's just super hardcore mode. Super hardcore mode. And then my favorite thing is when Elm Live does this. It's just like randomly crashes. I love when it does that. All right. Style. All right, let's see if we can make this a little bit forced bigger. See how that works. Nope. All right. I'm going to spend all night playing with design. So I think I'm going to finish this, if I can't get this working, and go to the other exercise. Excel. What? What is wrong with you, Excel? That's crazy. Well, okay. So to be fair, VBA script did change the world. I've seen some amazing things done with VBA script. So technically, that would be pretty cool. And considering the fact you're actually right, a lot of these are a lot of numbers, which then have calculations from previous cells. So I guess technically you could even do this with Excel equations or whatever those things they call them in cells. We get to equal. Yeah, that'd be amazing. All right, bear with me. I'm trying to remember where my div is here. Let's see, width of style. There we go. Okay, so if we go to our mass here, she's 120. That's good. That's good. And then let's make sure that her root is 120. And she is not. Oh, yeah. All right, let's try something crazy. Let's try 300. All right, I give up. I'll come back to CSS later. All right, so we got that. We now have to calculate the final value. So in our view, where's our view module? Right there? Okay, let's do this. Let's copy this guy. And we'll say calculate total fuel. Total fuel. And what was our model again? I can't even remember. Type alias model. Total fuel required. Okay. So our total fuel required is how much it costs to do the whole thing. And we'll say string from int. And our total fuel is 0 until we calculate everything. Once we calculate everything, let me make sure I did this right. So they want me to total fuel requirement, find and individually calculate each fuel for the mass, and then each module, and then add that for the sum. Okay. Whew. So last year I would get things wrong 12 times and have to wait minutes and minutes. And if I have to wait 12 minutes, so does this YouTube stream. So let's hope I don't get it wrong. So let's go to list.map, and that's our parser inputs. Let's calculate Calculate total fuel required, bruh. And the bruh isn't required. I don't know why I typed that. We take a list of modules, and list of module, and get an int back. Module list. And from this module list, we're going to do a list dot, and we use this a lot in these exercises. We're going to do reduce, and I've been doing this probably in Elm now for I don't know, 2 years, 2.5 years, and guess what? I still haven't memorized the argument order for reduce. So embarrassing. Reduce. I'm sorry, fold left, whatever. It is the function and initial value. Okay. Function initial value. Function initial value. Function initial value is, I think, probably 0, right? And then the module list. Let's say fold L. And I also forget, is it accumulator first? Or oh man, I can't remember. I think it's accumulator. I really no wait. I don't know. Let's figure it out. I can't remember. Import list. And we'll say A is 1, 2, 3. And we'll say list dot fold left. And we'll say accumulator and value, and we'll say B plus 1. And then we'll say 0, and then we'll say A. And then we'll say, let's say ACC and I for the increment, just to make so it doesn't get mad about shadowing. So I is the number for A plus 1. So let's do the same thing with 100. Okay, so we'll say accumulator, and in actually this case is the module, isn't it? Yeah, this is a module. And so we'll say ACC plus the module's fuel, I think. And why is she mad? Why are you mad, bro? Oh. Did I get backwards again? Is this the module and this is the accumulator? Oh, this is why the world invented compilers. Okay. Calculate total fuel required. This will loop through everything and add the initial module. So we'll go down to our parse input, where it calculates the fuel. Where's our modules? Modules. Module list, total fuel required. Okay, so we got to do it when we parse the input. That's fine. That's fine. Let's go to our update function. And where do we parse our inputs? So we get the module list. Let's also, while we're here, calculate our total fuel, which is basically this based on the module list. And then total fuel can be, oh, we can't do it here because this is only taking the input. All right, that's fine. We'll do it in the input function. I spent most of my time there anyway. So let's break it down. That's our total fuel. And let's get our parsed, whoa, careful. Parsed inputs. The module input. The model has an initial input of traction. You parse it. All right. So we can see our module list is our parsed inputs, and then our total, oh God, I can't even remember what I typed again. Alias model, total fuel required. Okay, got it. Total fuel required equals total fuel. Okay, why doesn't it, oh, my bad. There we go. All right, load the input. Parse it out, that'll give us all our mass, and that's our total fuel. All right, so I'm going to do the risky thing. I'm just going to take the first compile, put my faith in Elm in my correctness ability and paste it. Drum roll. I'm nervous. I'm super nervous. This is going to be embarrassing. I'm going to paste it. It's going to be wrong. That's the right answer. Oh, first try. Was there any doubt? Really? Did you see any doubt? I didn't see any. No one saw any doubt. Hold on. Oh, what's that? President Trump? No doubt. You didn't have a doubt either? Even the president had no doubt. What's up? All right. I've got 1 gold star. Continue to part 2. During the second no-go, the elf in charge of the rocket equation, double checker, stops the launch sequence. Apparently, you forgot to include an additional fuel for the fuel you just added. So you need more fuel. Why didn't he write that? Fuel itself requires fuel just like a module. Fuel itself. Oh, got it. Take its mass, divide by 3, round down, and subtract 2. Is that the same algorithm? Was it 3? Calculate mass. Yeah, okay. Any mass require negative fuel. All right, fuel. Wait. However, the fuel also requires fuel, and that fuel requires fuel, and so on. Any mass that require negative fuel instead should be treated as it requires 0. The remaining mass, if any, is instead handled by wishing really hard, which has no mass and is outside the scope. Wait, what? What did that just say? So for each module mass, calculate its fuel and add it to the total. Then treat the fuel amount you just calculated as the input mass and repeat the process, continuing the fuel requirement at 0 or negative. Okay, so I got to recursively check until it goes to the bottom. They have recursion in the first exercise. Like, this is crazy town. Absolute crazy town. All right. Repeat for the, okay. So we have to do a recursive calculate fuel. All right. I can do that. Let's do this. Let's check in what we got, and then we'll go from there. So ignore everything beyond Elm stuff. And we can check in the material component stuff. That's fine. But we don't need node modules. Once we check in this code, we can do the other stuff. Where is ignore? Okay. Good to go. Solved day 1, challenge 1. Master Blaster, 2 minutes, 1 minute leave. All right. I'm pumped. Ready for recursion, baby. Ready for recursion, baby. Let's do this. Go away. Calculate mass calculate fuel for fuel. And what does it take in? That fuel requires fuel. So take its mass divided by fuel. So that, okay. Fuel itself requires fuel, just come out. So take its mass, divide by 3, round down, subtract. However, the fuel also requires fuel, and that fuel requires fuel. So any mass that requires negative fuel. So the remaining mass, if any, which has the mass. So for each module mass, you calculate its fuel and add it to a total. Then treat that fuel amount you just calculated as the input mass. Okay, so fuel and mass are the same thing. That's not so bad. So you take the fuel, and which is an integer, and you're going to return an integer, which is recursive based on that. Okay, this is where this live stream goes horrible because I got to think in recursion, and I just, it hurts my brain. All right. I hate this part. Calculate the fuel required is actually calculating the mass. We need to calculate the mass. Fuel. I wonder if I can call myself case fuel of, right? Because like, hold on. There's a way to Elm case list. No, Elm base number. There's a way to do a case expression or pattern match on a 0. Case. Yeah, there it is. Case in of 0, 1, whatever. Okay, yeah. So I can do case fuel. If it's 0, then we're good. But if it's anything else, we want to calculate the mass based on the fuel, which is the mass. Is it fuel? I don't even know how to spell fuel. Oh my god. I'm freaking out. Fuel. Okay. Right, because that'll calculate it and then call it, but I don't want to calculate it. I want to call it itself. And you want to call this with whatever this returns. Is that correct? I'm going to call it again until it's 0, and then it just returns 0, and you're done? I think it's right. Is that right? It looks right. Let's find what happens. Okay, so let's play with this. Let's do message 1 log the right, and then we're just going to pass in the total fuel, but you can't because you need it for each individual one. Well, but no, that's fine. You can take the total fuel. That's fine. We'll do that. Let's see what happens. All right, this is either going to go well or it's going to crash the browser. And there it goes, crashing the browser. I think I crashed it. Crap. No. All right, well, it was a good first attempt. Actually, it was a horrible first attempt. So if the fuel you give it is 0, then return it because there's no need. But if it's any other value that's greater than 0, which I don't know that it works with negative, but I don't think it works with negative. Does it work with negative? Maybe we should have some balance checks. Ugh. Maybe we should not use case. Let's not use case. All right, my fan is speeding up, which means this tab is destroyed. Goodbye, Elm. You're destroyed. I thought Elm had no runtime exception and was when you compile, your application worked. Well, sync on recursion and lack of tail call recursion and lack of constraints around recursion. And, ugh, this is embarrassing. Okay. We'll say if fuel is greater than 0, then I need you to call me again. Else, if fuel is equal to 0, too much JavaScript, then return the fuel. Else, if fuel is less than 0, then just return the fuel. Let's try that. I think this will work. Okay. Let's try this again. Super embarrassing. I need some tunes, guys. I need some tunes. Because this is just frustrating. Let's do... So I need to focus because I get distracted by open offices and voices. So a lot of times I use drone and sometimes ambient because it tunes out. Like I like, rap and things like that and heavy metal and blah, blah, blah. But as soon as I hear words, I pay attention to that. So we're going to go find some really calming stuff that has no words. And these Mount Shrine guys, I think they're Russian. These guys are really good. All right. So if we load the input and parse it, does it crash again? Yep, parses it again. Yep. I got an idea. Let's do this. Let message 1 so this will print forever and then crash the browser, and that's okay. Not a big deal. Okay, let's give that a shot. Oh, was I missing the else? That's embarrassing. All right, I really want to get that case to work. There's got to be a way. I'm probably just missing some case statements. That's all right, though. You know what's interesting is it's not returning the mass. Crap. Because the fuel counts as mass. And the initial fuel is not what you passed in because it's what you pass in is the mass. Okay. So you need to pass in the mass you're dealing with and then the fuel that you want. And the initial condition is 0 because you don't know what fuel you're adding. But once you calculate the fuel, you can then pass it in and keep adding that fuel so it returns it each time. Or maybe I should just add it to an array and then reduce that. I don't know. Seems like it'd be easier to do inline. Phew. Okay. So we got the fuel calculation, which is going down based on how much you passed in, but we need to capture that. All right, that's fine. So if it's greater than 0, we actually do the work. So let's do the work. So additional fuel based on that mass that you just calculated is there, right? And that's the additional fuel that you say, yo, I got some mass. By the way, here's some additional fuel. You need to add this to your existing fuel that you currently have. Fuel is going to come into 0 initially, but each time you're going to continually add the additional fuel to the fuel so it accumulates over time. And the hope is that your mass will decrease as we've seen from the console. So hopefully this should work. So let's take the additional fuel and calculate additional fuel. We're going to take the mass that I just calculated, right? That's a new mass. And then we're going to add that to the fuel that we have now as the second parameter, and that should increase additionally. So we're going to say new fuel amount, which is basically those two, right? And then we can log both of those out. I can't remember. I think it was additional. Let's do a bunch. We'll just do a bunch. It's fine. Not a big deal. Mass, fuel, additional fuel that was calculated based on that mass, and then the new fuel amount, that's the additional value, and that we keep calling it. But you know what's interesting is that this returns the recursive value, which is correct, right? Yeah, because it's 0, you're just going to return what we got because there's nothing to add because mass is worthless. Okay, I think that's correct. Let's hold on. Hold up. All my homies be coding soft. We don't. Eat cheese every day. All right, let's give it a shot. Load the inputs, parse the inputs. And then, oh. All right, so mass and fuel, mass and fuel. The initial value for the mass and fuel is the total fuel, and 0 is what we start off with. Okay, let's try this again. Calculate fuel for 0. Oh, because he calculated the mass, not the fuel. My bad. If mass is 0, my bad. Atupido. Okay. Still need unit tests, ladies and gentlemen. Okay, so additional fuel. Oh, I hate how it goes in order. Curse you, Elm. All right, let's try. Can't even get logs in order. Okay. So the mass is that. The fuel starts at 0, and the additional fuel is 33. You got 3, right? Where's the new fuel amount? Why doesn't it print the new fuel amount? Are you just being a jerk on purpose? Whatever. And then additional fuel, and it just ratchets down. But new fuel keeps going up. Okay. So it calculates new fuel based on that. Okay, so far so good. And then calculate fuel for fuel. Give me fuel. Give me fire. Give me that which I desire. Which would be the answer. All right, now that we got our calculate fuel for fuel, we want to get our additional fuel. So that's the total fuel. Additional fuel accounting for fuel weight. Which is the additional. So let's add that. We'll say that. Oh, yeah. Sup? I do. I would love it. I would love some food. I'm almost done, I think. My mom always said it was rude to eat in front of people, but in this case, I think it's justified. Okay. It's an ASMR with seafood. You're silly. Okay, I love you. Thank you very much. Bye. The wife has summoned food for me. That's quite amazing. I should have gotten sushi, but I got the good stuff. All right, so additional fuel required for weight is going to default to 0. Save. And then in our update function, we need to account for this. So let's go to our update function here. Get rid of our log. And then this thing's getting kind of big. let's tab a little bit here. We'll add which will equal the additional food for weight. Okay, and then in our view, let's go show this guy. Oh yeah, gotta show it. If you're wrong and you know it, show it in your own code. If you're wrong and you know it, broadcast it live on YouTube. We need to copy pasta this guy and say additional fuel for fuel. Well, that's quite the variable name there, Jesse. Super Gigantor. All right, defaults to 0, defaults to 0. Load the input, parse the input. The additional fuel for that is that. Okay, and then what do we do with it? So there is a way to check my work, but I'm feeling brave, so I'm not going to check my work. What is the sum of the final fuel? For all the modules in your spacecraft, when also taking into account the mass of the added fuel. Okay, I can do that. I can do that. Let's go to our model. And we're going to say total fuel required. Final fuel required. So this actually should have been total fuel for modules, but that's okay. That's okay. We're going to go to update, bro. And we're going to say the total fuel required equals the total fuel plus the additional fuel. And then we're going to go in our view. We're going to add a new view for this guy. Copy pasta designing for the win. I married a designer, so I can't say that. Additional fuel for fuel. Total fuel required. Wait, did I really call? Wait, what? What? I don't even remember what I call my. Is it final fuel required? All right. Final fight. Whoa. Final fuel required. Adam Parrish, what's up, buddy? My UI isn't pretty yet, man. I was trying to do like a mask and like batteries, and yeah, this is embarrassing. Another thing too is I'm awful at CSS and HTML. So like, if it's not a component, like I'm like, not much I could do. All right, final field required. So is that right? I think it's right. All right, let's run it and test it. Oh, I forgot to wait. What? What's wrong with that? Oh, it's not the model. Oh, I don't know how to code. My bad. Let's go to the update and move the briggity bracket, squiggy brace, whatever. You're stuck in Atlanta. I haven't been to A-Town in forever. Toronto, dude. Canadians are nice. What are you in an airport? I don't miss those days. Okay, I'm lying. I do miss those days, but my sleep schedule is a lot better. Not sleeping in hotels anymore. All right, load the input, parse the input. Okay, moment of truth. Moment of truth. If this is truly the total fuel required, and we paste it in, it's gonna be wrong. I don't feel so good about this one. I think this is gonna be wrong. No. All right, I gotta check my work. Too high. If you're stuck, make sure you're using the full input data. There's also some general tips. All right, good news. They gave me a hint. It's too high. Okay. So I'm gonna do what I did last year. All right. So if it's too high, I wonder why. Let's create some test functions here. Let's go down to our calculate fuel required. Yeah, and he doesn't do total fuel required at all. Okay, so that's fine. What we can do is let's hold on to this guy for a minute. I want to save that. I'm gonna test this out in the REPL and see if I can duplicate the results. Can I paste this? I can't remember if I can paste this. I knew somebody would get the joke. The rent is too damn high. My input for the puzzle of day 2 is too damn high. Oh, well, there goes copy paste the coding for the win, not there. All right, let's try this again. Elm Rebel. All right, and then we'll go back to our calculate real quick. Calculate mass. We'll say, let's put these side by side. Calculate is the mass, which is the mass divided by 3. It's all integers. And then we'll manually write this one, which is mass and fuel. I forget how you do a line continuation in Elm. Is that it? Okay. All right, so mass and fuel are the 2 parameters. See you later, Adam. Good seeing you, man. Good chat, good chat. Too bad he didn't bring me the answer. Here's why your code is broken. I'll see you in Toronto. Be like, what? That'd be amazing. Like, yeah, I'm an Elm compiler in my past life. Yeah, I got some Haskell on my back. It's cool, man. It makes me super powered. I'll be like, hey, and good to see you, Adam. You got a growth on your back. That's not a growth. It's a superpower. Looks like a growth to me. No, it's a superpower. Then all of a sudden the growth climbs to you, and you're like, whoa, I can compile in real time. All right, so if mass is greater than 0, then calculate fuel for fuel. Oh, wait a minute. I need that. That's all right. We'll fix it. I need calculate mass based on the mass, and then I need additional. Well, that's pure function, so I can add it. That's fine. Calculate mass. Plus the fuel. Else, if mass is 0, then fuel. Else, if mass is less than 0, you gotta return the fuel. Else, return the fuel. All right. Let's give this a shot based on the inputs. So, calculate fuel for fuel based on 12 and a fuel of 0 gives you 0. Okay. So if we do the same thing with 14, it still gives us 0, and that's because it's down. Okay. That makes sense. So if we do calculate fuel for fuel, requires 654 fuel, then this fuel requires 216 more, which results in 311. 60 more fuel, 70 more fuel, requires 21 more fuel, requires 5 fuel, requires more. So the total fuel required for mass of 16 by 9 is 966. So if I do 654 plus 311, I get 965, and they get 966. Interesting. Oh, off by 1. All right, let's log it out because I might not get those exact numbers. Which is fine, which is totally fine. 265 requires 70 fuel. Okay, so we'll calculate the mass first. Calculate the mass of this 654. So that's correct. Then this fuel requires 216. So if I do calculate mass of 654, 216, that's correct. 216 requires 70. That's correct. And then 70 should require 21, which is cool. And then 21 should require 5. Banging. And then if you say 5, -1. Oh, but it calculates the -1. Okay. So am I accounting for -1? I might not be. So if I get negative, oh, okay. That's a problem. So yeah, we can't do that because that would give you negative fuel. Okay. Yeah, that's no bueno. No bueno. Not good. Bad. Horrible, horrible coding skills. All right, so what that means is we have to calculate the fact that we may get a -1. Which means that a -1 could negatively affect our algorithm. So if additional fuel is -1, it'll start adding things and cause all kinds of problems. All right, so let's calculate mass. Let's verify that it can't be greater than 1. The fuel is that, right? But then once we calculate it, we say if the fuel is greater than or equal to 0, then we're good, right? We can totally return that. But else, just return 0 because we can't have negative numbers. So let's do that. Dad digs it. Okay, let's try that. This might work. And then the update. Well, okay, so I fixed the off by 1 error, but it's still too high. I wonder if you're adding the fuel too soon. Maybe you're adding too. Okay, let's take a look. Update. Calculate the fuel for fuel. So I have additional fuel. I calculated it. It's 0. The new fuel amount is whatever, so it doesn't negatively affect it, which is great. I guess what's interesting is that if additional fuel is 0. Okay, let's try it. It could be if additional fuel is greater than 0, then we're good. Otherwise, don't do anything. Just return the fuel, bruh. Right? We're good. All right, start again. Nope. No change. No change. I'm having flashbacks of last year. So frustrating. Calculate. So it's weird is that the algorithm was working with not the -1. Maybe I missed something. Let me reread it. Yeah, that's cool. That works. Interesting. I see. All right. Well, how are we using this guy? Do you have to calculate it like on a pure fuel basis? Maybe that's the problem. Okay. I don't know. Let's check it out. Let's check it out. So let's go just playing around here. Playing around. Let's take a list dot map, right, of the modules. So we have the modules. And when we get that module, what we're looking for is the module's fuel, but we want to calculate additional fuel for the weight. So we're going to do the M fuel required with a starting count of 0, because that's the mass. And then that'll return the accumulated value. And then we can just print this out. And see what those individual values are. Let's do that. Okay, so we got some individual values. That's cool. Let's then add those together. Is there a list.sum? Yeah, let's do that. Okay, that's the total. And then, so maybe. Yeah, let's keep it right there just in case. Just in case. You know what? I just realized I could probably just calculate that in the type. It'll make it so much easier. All right. Before we do that, let's go ahead and add this up to the other guys. Yeah, let's do that. All right, so we summed it together. And we have additional. Okay, so that gives me that. Okay, a lot better, a lot lower. Let's try that. Yes, yes. That rush. 20 years later, and you still get that rush of like, I am awesome. Right? I am awesome. All right. You have completed day 1. You can share this victory to Twitter or Reddit. Man, I don't need to share nothing. I got nothing to prove, yo. You know what I'm saying? I'm Jesse Warden. I got the Haskell power. I borrowed that from Adam Parrish. You know what I'm saying? I don't know what I'm talking about. All right. Well, that was day 1, ladies and gentlemen. I'm going to try to pretty up this code. You're welcome to stay. I'm going to go get some food. And what I'm going to do is see if I can take these modules and decorate it in such a way where they show like little gauges of how much fuel is, and then calculate another graph that shows the additional fuel based on the weight, and then see if I can do like a mask, because I've done masking in CSS once. Put that and then we'll adjust some margins or whatever, and then put it up there when it's constrained its height, so you don't have to have that stupid scroll thing. And then I'll go ahead and upload the code to GitHub, add some comments, and we'll be done, man. We'll be done. Yo, what's up, E? So today is, I literally just completed it, like right when you joined. So today's is day one of Advent of Code 2019. And every day they give you 2 challenges, code challenges that you have to complete. And they're very different than what I'm used to from a UI, API backend perspective. It's a lot of algorithms and math and things like that. And so what we're doing is I'm taking a statically functional language and building a UI around it to get practice in recursion and CSS. And so I just completed it, thank God. And everyone can get the same algorithm. Like you can play, the same algorithm within Python or JavaScript, doesn't matter, but you have different inputs. So although you might have the same function, your output that the contest requires is completely different. And so some people do it for speed, some do it for challenges. I just do it for fun to learn. So I'm gonna go get some food, come back up here, and we're gonna start, see if I can make this a little bit prettier. So we got 2 stars, man. Banging, super banging. So we got to do all these stars to rescue Santa, and we got 5 hours until day 2. I am definitely not staying up late to broadcast that, but I might take a peek so I can think about it. All right, so let's save this. Guess number 2. And I will be right back. .com. All right. This is the fun part where you get to make things pretty with no stress, no, what's the word? No self-esteem issues, because you're just like, you're having fun. You were having fun, but you were pressured to feel smart, wholesome, accepted by your peers. But this way, I really don't care if I struggle around in CSS because I solved the puzzles. Oh, yeah. All right, here's what we're going to do. I think in order to display it, we have to refactor this code to allow the calculated fuel amount to be in the actual module so we can draw each individual module rather than, calculating it like I'm doing right here. So we might have to do it while we're calculating the fuel, which I think is fine. I can do that. Let me get my power cable and then I'm going to refactor it. I have the power. All right, I'm running out of plugs in this place. I may have to steal one of my lamps. That would be awkward. That would be super awkward. Let's try it. It might work. You never know. There we go. These Apple cords make it really easy to share. Keyword, I'm being super sarcastic right now. I'm sorry, how sarcastic, Jesse? Super sarcastic. All right. Time to refactor. Did I check my working, right? Go away. Nice, okay. All right. So happy, man. So happy. And I'm happy that I can remember recursion that fast. It didn't take as long that time. So let's take this. We're going to go to calculate total fuel required. We're going to build this in. So see how it does the accumulation of the fuel in a single pass? What we need to do is this in a second pass. So let's figure out how to do that. That way we can actually draw like kind of like a little bar chart that'll show both values. I hope you're presentable. Okay, you can say hi. What's up, ladies and gentlemen? This is my daughter, Sydney.
Nobody can see me.
This is my other daughter, Rowan.
Ow, I hurt myself.
I hope. Are you presentable? You both presentable? Okay.
Yes. Dad, why do you have a hat on?
Hey, because my hair looks awful. You don't think I look better without the hat?
Wait, I want to get my face. I can see me there.
Let me go to update. Yeah, it's delayed by 20 seconds.
I was sad.
Let's see. Update.
Are people watching it?
Yeah, man.
How many people?
So I solved the first two puzzles.
Oh.
Which are really hard.
How many people
There
are?
are only 4 people watching him.
That's okay. It's recording it, so people want to watch later.
Hi, 4 people.
Where is additional fuel? All right. So let's go to the type alias module. And let's add fuel for fuel. Because you have to account for the weight of the module.
Okay, I'm gonna go. See ya.
Later, ladies.
Bye. No, I'm still here.
Oh, you stay here?
Look at my bow. Isn't it cheesy?
What does it say? Time what?
Time to slay.
That has cheerleader written all over it. All over it.
I know, right? And it's so cheesy, I had to have it. I'm wearing it to school tomorrow.
I'm sure you'll look adorable.
I know, right? Wait, how am I gonna match that with my clothes?
It sounds like a hard problem.
I'll just wear like brown.
Modules. All right.
What's
Well,
a module?
a module is a piece of the space rocket, and each module weighs something, and you have to calculate how much fuel does this require. However, the fuel itself adds weight, so you have to recursively add enough fuel for the extra fuel of weight you added
Okay,
to push
okay.
that in space.
How does that relate to coding?
Because you got to calculate how much fuel it costs to get your rocket to space, so you can go into outer space and save Santa Claus.
Why are you coding about saving Santa Claus?
That's what you do every year. It's called Advent of Code. And so after we go to all 50 stars, we'll get enough information to figure out how to get him back or whatever. All right, so we need to do this right here. So we have our fuel and our modules. Let's go to the update though, because we got to parse the inputs based on those, and then calculate total fuel required based on them.
Is this a competition?
It can be. There are a lot of people who are competing either for time or they're using like all the same language and they agree. My company actually has a leaderboard, which
Cool.
so this is the leaderboard for everybody.
Where are you?
Oh, honey, I don't mean to break it to you, but your daddy ain't gonna be anywhere near the top of this list.
Why?
I'm not a competitive coder, man.
You should be.
I appreciate that. Mine was. I'm trying to figure out where mine was. There was a stats for my company. I'm trying to figure out where it was.
It's delayed by 20 seconds.
Yep.
Oh my gosh. Guys, you're only seeing the past. They're in the past and we're in the future.
I thought I already joined the other leaderboard.
Bye.
I'll have to see it. I don't know.
Wait, do they want to see Albus?
No, they do not want to see Elvis. They've already seen Elvis.
Yeah, he's fat.
Oh, I'm number 4 in my job. What's up? What's up?
Number 4? Wow, I'm disappointed.
I know, right?
I still love you though. Bye.
Depressing. All right, so from the parse inputs, we can actually do the whole thing. So that'll start us off with each module, and then we'll then, after we calculate it a second time, well, no, we could do it right there. That's fine. We could totally do it right there. All right, so here's the thing. When we parse the module right here, we just need to do the total fuel calculation, right? Which is calculate fuel for fuel. So what we'll do is see, and then if we print it out, yeah, right there. That's good. All right, so let's fix this list here. I'm going to take that and convert it to some kind of like progress bar. All right. That is fine. Let's go to the view. And let's clean some things up here. First things first. Style for this card is a little too big. There we go. All right, much better, much better. I dig this. Okay. Calculate fuel requirements. Oh yeah. And then we're gonna let's see if we can get a progress bar here. Takes in an integer and returns an HTML message. And all it is a div, which has a div. And this has a style, background color, I don't know, red. And this has a style. Let's do this, style width of 100 pixels, and this has a style background color of blue, and a width of 50 pixels, and a height of, I don't know, 12 pixels, I guess. Go. And then where's that loop-de-loop? Right, the mass and the fuel. Instead of all this, let's just do a div that has a view progress bar of, I don't know, 50. See what happens. Very cool. Okay. And then perfect. Okay, that's a lot better. I like this. Okay. So we need the mass, fuel, extra fuel. So we actually need 3. Holy. Okay. I think you can do 2 divs. Can I do 2 divs? How do I do that? Like a progress bar with a progress bar. There's got to be a way. Let's take a look. How do you do... Well, I could easily do this with Canvas. Or I could just do 3 divs within divs. I don't know. Let's try it. Let's try it. I think you can do a div within a div within a div. Yeah, let's go. Yeah, it's broken up. Okay. What if... What if we did this? Nice. All right, so you have the mass, and then that, and then each one will give you your total width based on your mass and width, calculated by what the average width is, which means that... No, you don't need to do that. You just calculate it, right? Like, can't you just say, out of 100? Yeah. Yeah, let's do it out of 100. So, like 17,000 would be X percentage of max, but you have to know the max. Okay, we can do that. We can totally do that. Let's do highest mast, highest mass, highest fuel. Now, what is a big number here? It's 13,000, 27,000. So 80. All right, so let's just find the highest mast. We can do that. We'll say highest mass. Take a list of modules, get the highest mass. Once you have the highest mass, you can calculate what is the largest amount of thing you're going to draw. That will be your 100 pixels. Everything after that will be a percentage of that particular value. So we'll get that. All right, kiddos. I'm going to spend the rest of the night on this. I will see y'all tomorrow while I finish up this. You're welcome to stay as I do it. Just be aware, day 2 also has 2 exercises. And so I'm going to try to do that after work tomorrow. Let's take the total mass, which is a list of reduce, fold L of a module. All right, what we need is the max percentage, max mass, right? And then from that mass, we can use that as the max size. So we'll just say max size. And that'll give you the percentage of how big you're supposed to be for your total. Well, no, because you have to add it, don't you? Yeah, but we can do like 80%. Right? That'll give you some flex room. We'll do that. That's good enough. That's good enough. We'll eyeball it. Let's say the 80, right? It's like the 80 percentile. So we'll say if you make this about 200 pixels, yeah, 200 pixels times max size divided by 200. That'll give you like the average or the max, and then everyone after will have to divide by that to get the percentage of the 2 pixels. Okay, that's fine. So let's take the progress bar and give it a little info. We'll give it the module, and then from the module, he can calculate how big he is based on the largest module. Largest mass, module yo. And we'll say largest mass divided by module yo mass. So if my mass is like 80,000 and the largest is 100,000, then divided by 80,000, they're going to be 125 minus 100, which give me the largest mass size. Based on that, I can use that as the size for like a total of 100 pixels. Okay, I'm cool with that. So we'll make him 200 pixels and use that as the 80. That multiplied by 100. So that is 100 minus the largest mass out of that, which will give you the pixels. Okay. So the first one is going to be the mass. So this will be string from int. Is that it? Int. Which will be the 80. And then we'll add it to this guy. That'll give us our pixel length. So we'll say mass width, right? And then well, you know, if we do 300, that gives us 100 pixels for each. I kind of like that. Because like if everyone was a certain size, well, let's play around. Let's play around. We'll do 300 and see what happens. So we'll say 300 mass width, fuel width, module yo fuel. Yeah, okay. That'd be your largest mass divided by your fuel. That's good. That's good. Let's do the same thing for Yeah, let's do the same thing for mass width, fuel width, fuel for fuel. And based on that, we have 300, and we can say the mass width, the fuel width, and the fuel for fuel width, right? And what that allows us to calculate is all of it. Now, I don't know what current is. I don't think current matters, actually. Okay, so largest mass, let's see. Yeah, but you need to call me with the largest, which is model dot largest mass. Sorry, man. I need that variable. And it's a closure, so we'll do model dot alias model. And we get the largest mass. And then in the update function, equals the calculate highest mass. And then what is his, he just needs the modulus, right? Okay, modulus. And then in the is that it? In the type alias, largest mass? Yeah, okay. Oh, actually, now that I think about it, this view module needs it like that. There we go. All right, so he's expecting a float. So let's go to 266 and fix it to integer math, because it is not a float. It is an integer. Okay. Cool. We're getting somewhere. Okay. Where's sup? This is going to be a combination of things. So let's say the mass, the fuel, and then fuel for fuel, which is the modulo, fuel for fuel. And then say string from int. I'm just going to take out the string part. Am I allowed to do that? No? Okay, fine. String from int. That'll convert the integer to a string, so you can then add it using the plus plus. Okay, that'll give us our numbers. And then from that value, so why is the blue wrong? Whoa, careful, bruh. What's up with the blue? So RGB, so he's good. His is fuel width. All right, let's print them out. Maybe there's something weird going on. Let's see what the mass width is here. Sorry, the mass, largest mass. Let's try that again. Also, somebody's logging this guy out. Yeah, we don't need to see him right now. All right, largest mass stays the same, which is fun. That's good. But what I'm interested in is the mass width. Aha, negative. Okay, so largest mass divided by mass. Talk to me, goose. I need to know what this number is. Right here. What is this? This will be the key. Oh, it's integer math. Okay. So, interesting. All right, I have an idea. So I might be calculating the total wrong. Let's fix that. The total, because the total has to be a percentage. However, I'm unclear as to what she is calculating. So like if you have, let's say, largest mass is 94,000, then you have this, you get 89. All right, let's test it out. So we'll take this, A. B is, yeah, so let's just do it right here. We'll do divided by integer math. That's fascinating. All right, we actually need a float. So, actually, I think we need to reverse it. Let's try that. 111,666 divided by 994,1651. 994,1651. Yeah, you can't do it without floats. All right, let's do floats. Mass float is from int module yo mass fuel float yo, and then fuel from int module yo fuel from fuel, and then we'll take the mass float minus that, and that'll give you that. But we could floor that. You just say floor, right? Or round. Say round. Right? we go. Okay. And then from this, calculate I guess percentage, right? Taking in the largest mass float and some value, right? And then, yeah, we'll round it. That's fine. So we'll do a round of whatever your value is divided by your largest mass float. And then if we do that, largest mass float value, calc. Yeah, and then what we can do is say mass float. Here, we can say calc fuel float, right? Do the same with this guy. And this will give you floats, and then you should be able to have a little better values there. Okay. What if I said mass float divided by largest mass float? Will give me total? Yeah, I don't think it's that your percentage multiplied by 100. Interesting. Well, if you take that percentage and you multiply it by 100, it should give you a good value. Why is this being stupid? Let's take a mass float. What's total? Let's just show me some totals, bro. That's all I care about. Yeah, but even the largest should be like 1. You know what I mean? So let's take the largest mass float. And the module mass float. Are you sure? Yeah, all you're doing is adding it, you moron. Okay. If M mass is greater than ACC, then M dot mass, else ACC. There we go. Much better. Okay. So the largest mass is like that, and then let's go down to the view. comment this out just for a minute, just so we can play around. Let's see here. How does that look? I sort of think 200 was too much, or 300 was too much. Maybe it is too much. I don't know. I'm thinking we can get away with it. All right, let's calculate this. Where's the text? Also, I don't think I need 300 or 200. I think I can get away with like 150. Right? You do that. Yeah, and you might not even need a background color, bro. You could probably just like say nothing. Right? Yeah, that'll work. Okay. Dig it. All right. Let's this actually might be better for a table. We could do that. I don't want to though. Let's just let's give it some better stuff here. So we'll say all right, this will read a lot better. Fuel. All right, I'm gonna have to call it a day soon, guys. The girls are asking for ice cream. Fuel. Style. This flex direction. Which way? Row or column? No one knows. You know, I wonder if I could put that on the right. Might be able to. Let's try it. Yeah, it's not aligned correctly. What if you did that might work. Nice. All right, let's set some spacing here. It's a little obnoxious. Is there a way to do the same thing? Let's try it. All right. That's it for now. I got to get the girls ice cream. I'm probably going to go on my one wheel or something. All right. I'll see y'all day 2.